Okay, so this is number 6 from your extra exact value practice. And I'd probably say it's one of the tougher questions on the sheet just because it's building on skills from numbers 4 and 5, as well as the triangle's just more complicated, right? So the there's one problem with this question is that it's not that the area of a triangle ever changes to calculate it. That's always going to be 1/2 the base times the height. The problem with this question in particular is the base has been broken up into 2 components. And so I'm going to have to find B1, what we're going to call B1 and B2 separately. And then subsequently our base of this triangle is going to change to be B1 plus B2 times the height. Okay, so we're going to, our whole focus around this question is finding B1 and B2. Okay, and B1 is going to be a little bit easier to find than B2 for reasons that will become apparent as we work through this question. So we'll start, while the question is very clear and there's nothing on the triangle yet, we'll start by solving for the more complicated side length, and that's going to be B2. Our problem right now is I do happen to know that that's going to be 45. Okay. But alpha has been told to me, but it's been told to me in an indirect way. So it's been told to me via that. It's told me the primary trig ratio. Okay. So the sine of alpha is going to be 1/2. So if I drew a triangle right now, and I was interested in, this is alpha. I want to know what alpha is. It told me that alpha, and specifically the sine of alpha, is opposite over hypotenuse. And so I know the side lengths on this particular triangle are going to be 1 and 2, which looks awfully familiar, or looks very similar to, if not identical, it is identical to, if I put a root 3 there, that's my 30, 60, 90 triangle, which must make alpha 30 degrees. Okay, so with that information now, the problem is one of the side lengths has been proportionally changed, right? So this should have been, if it was the 30, 60, 90 triangle, which it still is, it's just bigger, right? The side lengths are larger. So instead of it being root 3, it should actually be just 3. So we need to figure out, although we may think that that's 1 and 2, these have been multiplied by some scale factor. I'm not too sure what it is yet. That's what we're going to find, right? I need to take whatever that scale factor is and multiply it by what would have been 1 and 2. But I'm going to figure out what that scale factor is using proportional reasoning, if you will. And that's what we've been doing for questions 4 and 5. That was a lot of words for work that we did in 4 and 5. So what we're going to do is I'm going to write the sine of 30 degrees has to be equal to, in this case, it's going to be, I don't want to use this, the hypotenuse, right? So, and I don't want to use it because that's not really the right number, and nor is the 1. So what I'm going to do is rely on the fact that I do know some known information for my triangle. I'm actually not going to select sine for this, right? Because sine uses the information that's unreliable, or it hasn't been proportionally changed, right? It hasn't been multiplied by the scale factor. So I'm going to use the information on the triangle that has been affected by that scale factor. And to use that information, I'm going to have to use tangent, or something that involves the adjacent side length relative to 30 degrees. So for this question, because I'm interested in B2, right? I'm interested in that, and this is the information that's been told to me on the triangle. That is the opposite side length, and this is adjacent. And so I'm going to use the fact that sounds like tangent to me. So I'm actually going to use tan of 30 degrees. Relative to the triangle is going to be B2, B2 divided by 3. Okay. Now for 30 degrees, as we've established up top here, that alpha was 30 degrees. Your eraser's a little big. The tangent of 30 degrees is opposite over adjacent. Okay, so this has to be equal to 1 over root 3. And so now, you know, I've kind of written out the fact that tangent is 1 over root 3, or tan of 30 is 1 over root 3, and I'm going to use this fact now to solve for what B2 would be in the new proportionally scaled up version, right? So whatever's been multiplied by that scale factor, right? So I'm going to go root 3 times B2 has to equal 3. And so B2 is actually going to be 3 divided by root 3. And I never leave anything with a rational or radical in the denominator, so I'm going to rationalize root 3 by root 3. So B2 is going to equal 3 root 3 by 3. 3's drop out. So B2 is going to equal root 3. So that was a lot, but remember at the beginning of this question, I said B2 was going to be the harder of the two to find. And I know that that's the case because I can do the same work to find B1. It's just going to be with the 45-degree triangle. But on our triangle right now, we know one of the properties, if I drew out my 45-degree triangle, and this is why we like the 45-degree triangle, because it's the easier of the two to memorize because of the fact that I'm going to pivot on here. So if this is 45, that's 45, this is 90. We know the hypotenuse in the 45 triangle is root 2. We also know that because these angles are equal, these side lengths have to be equal as well. That's where that's come from. And so if I'm looking at this triangle here specifically, the one I'll highlight it actually. Okay, if I'm looking at that pink triangle, I know that the side lengths that are not the hypotenuse are 3, right? Because it's been provided to me, and because that 3 is opposite of 45, then B1 must also be the same side length of 3. And I can prove that using the triangle, which I'm going to not do for the purposes of this video, but I can do the exact same work that I did here to prove that that's the case, because the ratio for tangent to 45 is 1 over 1. Okay, so we know, just based on pure geometry, that other side length B1 has to be 3. And so now we're in the stage that I can actually calculate for the area because I know the two bases, and I also know the height of the triangle is going to be 3. So let's just do some calculations now. So the trig portion is over. We're now just going to, this turns into almost a BEDMAS question, right? Where looking at orders of operation, it's just going to have some radicals in it, which is going to be a little uglier. So A is going to equal 1/2 B1, we learned to be 3, plus root 3, and we're going to multiply that by 3. So what I'm going to do is distribute the 3 in, and then multiply by the half after, just to keep the fractions out of the question as long as I can. So I get 9 plus 3 root 3. And now I'm going to put the half in. So A is going to equal 9 by 2 plus 3 root 3 by 2, which you could rewrite, and this is the way that the answer is written, 9 plus 3 divided, 3 root 3 divided by 2. And you could even, I suppose, if you wanted to, either of these would do, I suppose. Okay, so that should be your answer. Pretty loaded question. That's a toughie, but it's just building on some of those skills, and it really illustrates your ability to make connections between the special triangles and how they've been scaled up proportionally. or down. Okay. So a little proportional reasoning for you there in that question. Okay, so we'll see you in the next video.